Hi, in this video, we're going to learn how to do simple calculations with fixed area plot sampling. So I'll get to fixed area plot sampling in a minute, but I'm just going to write that up here. And when we take data from sample plots in forests, we have to do a bunch of calculations with them. And collectively, I like to call this plot math. So this is the math that enables us to transform the underlying data into useful numbers. So let's start with a forest. And let's say we have a mountain and a valley. And down in that valley, there's a forest that we own or we're managing for somebody. And this forest, let's say that it's 50 acres in size. So we might want to know a whole bunch of different things about this forest. We might want to know how many trees are in the forest. We might want to know how big the trees are, all sorts of numbers that we'd want to generate. But let's start with a simple question. How many trees are in the forest? Okay, so think about the process of going over 50 acres and counting every tree. That would be very challenging to do. So instead of actually going and counting every tree, we're going to count a sample of trees and then extrapolate that out to the entire property. Okay, so that's where the sampling comes in. Now, fixed area plot sampling basically means that we're going to have an area in the forest that we're going to count some trees on, but it's going to be a lot smaller than the area we're interested in. And we're going to repeat that a bunch of times throughout the forest, and then we're going to get a bunch of those counts and then come up with the numbers. So the particular type I'm going to talk about is what's called fixed radius sampling. And a fixed radius plot is a situation where we go into the forest, and here we are, and we're going to put some kind of a pin or stake in the ground at a sample location in the forest. And then what we're going to do is we're going to measure out a radius of a certain length, and that's the radius of a circular plot which will contain some number of trees at that location. Right? So we're going to have a small circular area. We're going to repeat this a bunch of times throughout the forest. And then we're going to count the trees in these smaller areas and then use that to figure out how many trees there are in the whole area. Okay, so that's fixed radius plot. So there's a whole bunch of different plot sizes we can use. We can use big radiuses, small radiuses. If we have a large radius plot, then we're going to get a lot of trees to count. If we have a small radius plot, we're going to count fewer trees. A common plot size is a 1/10 acre plot. Okay? That means that the area of the circle is 1/10 of an acre, and 10 of them would be the equivalent of 1 acre. So if we go back to our basic geometry, the area of a circle equals pi times the radius squared. So what would the radius of a circle with that area be? So that radius is equal to the square root of the area over pi, which I'll just make it simple and tell you that that's a 37.2 foot radius to make a 1/10 acre circle. Okay, so what does this data look like? So basically, we're going to have some number of plots. And we usually use lowercase n to indicate the number of plots. And then we're going to have some kind of a data sheet that's going to show the plot number. We give each plot its own number. And then we'll make it simple data, and we're just going to count the number of trees. Okay, So we're going to have plot 1, plot 2, all the way down to n. So let's say the first plot has 13 trees, and the next plot has 18 trees, and the last plot has 7. So now we have the count of the number of trees in each plot. Okay, so what we want to know next is the average number of trees per plot. So let's say that the letter T is subscripted with an I equals the number of trees in plot I. Okay? So if you remember your average, the way an average works is we sum all the values from I equals 1 to n. So this basically means we're just summing all of these, adding all these numbers up, and then we're dividing by the number of numbers. Okay, so this gives us the average trees per plot. Okay, so now we know the average number of trees per plot. Let's say that that number comes out to be 15. Okay, so 15 trees per plot. What do I do with that number? That's a number that's hard to visualize. And in forestry, we express almost all values on a per unit acre basis or in the metric system on a per hectare basis. Right now I'm working in the English system, so we're talking about acres. So how do we convert average trees per plot into average trees per acre? Okay, well, we need to know the number of plots per acre. So a really important equation here for doing plot math is value per plot times plots per acre gives us value per acre. Okay? So let's use the numbers that we've already generated to solve this. Okay, we've got, in this case, the value is the number of trees. So we've got 15 trees per plot. Now, if it's a 10th acre plot, there are 10 plots in an acre. So times 10 plots per acre equals 150 trees per acre. Now think about that number again. So we went in and we got an average of 15 trees per plot. And if we know the plot's a 10th of an acre, then on a whole acre that would be 10 times that, or 150 trees. Okay, so that's a useful number. Again, a lot of numbers that we use in forestry are expressed on a per unit acre basis. So we would say this forest, across the whole forest, has an average of X per acre. In this case, 150 trees per acre. So let's get back to our original question now, which was, how many trees total? So here's where we bring in the total number of acres. If there's an average of 150 trees per acre over 50 acres, 50 acres equals 7,500 trees. So from going out across the property and coming up with this average and just counting smaller areas, we can now estimate, and I like to point out this is an estimate, 7,500 trees are out there. Now, why is it only an estimate? Because we didn't count every single tree. And the way that this works, basically every tree represents 10 trees, or 9 other trees, or 9/10 of an acre that we didn't collect measurements on. So that's the basics of plot math. And in the next video, I'm going to show how this is applied to calculating forest carbon, or what I'll call forest carbon math.